Okay. All right, then. I'm making a recording for future reference. So let's archive this. Let's see. So what I was hoping we could do, I kind of forget, of course. So, whoa, I didn't know you could do that. It's kind of cool. Must be a new feature. So I was hoping we could talk a little bit about chalk query structure, which I've been meaning to think about anyway. So I think that's pretty relevant. So like we were gonna do, or the overall plan around specialization, before we go there, make sure we're in agreement on this. The overall plan that we were working on was to, given that one impl A specializes another impl B, we can adjust the rules around projection so that B wins. And in particular, we basically have to adjust the rules for impl A, because impl B, or rather, the point is, any default type that's a potentially specialized type. So that's where we need to adjust the rules. We probably may or may not. In real life, we might want to change the rules for all types to account for erroneous programs that people didn't use default, but still had specializations going on. But we can worry about that later. The question is, I think it was sort of clear, or I think we covered last time, like how, or in my notes I covered somewhere, how to adjust these rules, kind of. Is that true?
You're talking about in the GitHub issue?
Let's see. Is this the GitHub issue, or did I make a new one? I think I made a new one.
I just pasted a link to it.
Yeah. So something like this, which you had already started to do.
Yeah.
So then the question is, sort of, when do we generate these overrides impls? And also, I think in general, our query structure is a little bit wrong. Sorry. So what I would like is that, you think, when what happens is we have the okay, we get a request for a callback. Let's open up the chalk source a bit. So we have this rust.ir database thing, and at some point we get, or rather we have this chalk solver, I guess is where this comes from. We get a request, a kind of callback for what are the program clauses for a given goal. So I have to find where that code is.
It's not in clauses.
Yeah.
In clauses.rs program.
Yeah. I'm still not used to the non-mod RS thing.
Right.
So And this is really a place where ideally I think I'd like to do some caching, but this interacts with the rust.ir database. So the tricky part is here, this code, so we have this function, program clauses for goal.
Mhm.
And that's going to have to, what we want to do is generate, okay, let's just jump back 1 second. So the override, let's come back to the original question. When do we generate these overrides clauses? And the answer needs to be basically when one impl specializes another. I think this, if I did it, if I recall, this ID, this overrides were tied to a particular associated type, right?
Yeah, that was the idea of an associated type in an impl.
Right. So when one impl, so when impl B specializes impl A, then we would generate for each type in impl B for each and we kind of let ID A be the ID of the associated type in impl A, I think, and generate overrides of ID.
Now, what about for the trait ref part of this as well? Because we also have like foo t, or I guess,
Right.
yeah, it would be a foo t iterator or something like that.
Right. So if impl B is for the, so let's put it, let's say, let trait ref A be the trait ref from impl A, and let trait ref B be the trait ref from impl B, then this is going to get generated for trait ref B. And really, you're going to need some, whatever the where clauses are from trait B as well.
So is impl A this foo t iterator thing? Oh, okay, you're using the same example from before. I'm going to copy that example.
No, impl, I mean, yeah, give the example. That would be
Yeah,
good.
there we go. That could have.
This would be, so in the case of the example above, I believe we would generate overrides v0 foo of string. In other words, we take it from impl B, right? And the reason is impl B is overriding that item for those cases that it applies to.
Yeah.
So really, this is not relevant here. So it seems like program clauses for goal, when the goal is overrides of v0, v for some v, needs to walk all impls. I mean, really, it needs to walk all impls that potentially override the impl containing v.
Okay. Yeah, that's fine.
And for each of their associated types, generate clauses, sort of, or however it gets set up. But
so the associated type, or I guess impl A, would be at some point in the specialization tree, and we would have to look at all of the subnodes and all the subnodes of the subnodes to
yes,
find other impls, and then generate override clauses for that.
right.
So that means that this function needs access to the specialization tree, right?
To the tree?
Yeah.
Yes. So right now, let's take a look back. Right now, there's the rust.ir database trait. And then separately, there's in this coherence module, there's this thing called the coherence solver, which you can instantiate for a given trait. And you can ask it to create specialization priorities, which is pretty much the specialization forest, if I recall.
Yeah.
And yeah. So I think this, I think what we want a hold on a second. Yeah. So we could do this in a few ways, depending how much we want to like tie to the use of chalk. I think probably we don't, sorry, not chalk, to the use of salsa. I don't think we probably, what we basically want to do is have some way for the program clauses code to invoke this specialization priorities function. But I don't think we want to do it directly. Instead, I think we want to do it kind of through a trait. And right now, right now we couldn't call it directly anyway, because we don't have the solver choice that we need, which basically says what solver to use, which is fine. I think what we want, so one way to go about this would be is to extend the rust.ir database trait. Let's do this. Option A. Extend the rust.ir database trait. We would add a specialization tree something like this method. And in the chalk integration crate, this will be mapped to a salsa query probably that invokes the code from chalk solve coherence module. So what would happen in the flow would be like chalk solve clauses invokes chalk solve invokes the specialization tree method, which is implemented in the chalk crate. And then that in turn invokes chalk solve coherence, which will recursively use the clauses code. And this little like indirection through the trait gives the integration crate a chance to pick the solver and detect cycles and fail in some way. At the moment, panicking is probably good enough, which is what would happen by default. That seems okay. The other option would be the way Salsa is set up, you can sort of have partial databases. So we could have like a partial Salsa database in chalk solve that says, I offer the following method, specialization tree, and I extend the rust.ir database, or I require the rust.ir database trait, and then we could use two Salsa query groups. But I think I don't see a lot of advantage to that, and the disadvantage would be that if you wanted to integrate the chalk solve into something that's not using Salsa, you sort of couldn't. Whereas here in option A, you really have more flexibility.
Okay, that's fine. Are we rebuilding the specialization tree for every IPL? Like, weren't we doing it only one time before?
Well, you'll note that it's tied to the trait.
Yeah.
So it's not every impl, it's every trait. And using salsa would get cached anyway.
Okay.
So you would only do it once per trait. Currently, we do it, I don't know the answer.
I think we do it for every trait.
For every trait, we do it. Yeah, so the difference would be here also that you would only do it if you needed it in this setup.
Right.
If you have a default type somewhere, then you'll generate an overrides goal, and when you go to solve the overrides goal, you'll create the tree. But until then, you wouldn't. And this tree, let's see. I don't really remember what shape it has, but presumably, like, what is a specialization priority? It's probably just a number. Yeah, okay. Right, so we can then use this. So if you had, once you get this tree in an impl, you can basically iterate over all the impls with lower priority than you. Right, and generate an overrides for them. It's a little bit crude.
Yeah, I was thinking that too.
You'll have some false. You'll kind of have some false rules, so to speak. Like if you had something like this. You have this set up. Presumably, I don't know exactly what priorities these would get, but it's plausible that this could get, priority 0, whatever, priority 1, and hence you would have overrides. I don't see that this is harmful, but that rule is correct, but you would also presumably get this rule, which is not useful, kind of, because box of T.
But wouldn't you start from V0, right? Like you would get something like in that function, you get like overrides V0 with foo, oh no, sorry, with vec_t foo, right? Yeah, and so this would.
I think here you would get normalized rec of T as foo. Oh, I wrote the wrong thing. This should be bar.
Right, yeah, it's not. That was close. Yeah, so you get this, and then because you have this V0 here, wouldn't you be able to use that to only get the third impl here? Like, why would you also generate the one for V1?
Well, for this rule, you're also going to make a rule like so, right? And then now the problem is when we go to solve find all the things that implement overrides of v1. We're going to find this impl. We're going to see that it has higher priority than the impl containing v1. So either we'll generate, if we don't do anything else, we would generate this clause.
Oh, I see. It's because we're iterating over all the ones with lower priority.
Yeah. I mean, you could do more work to figure out if this is like, is this actually a parent or is it a non-related branch sort of tree of impls? But that's kind of annoying because we already did all the work to build this tree in the first place. I think it would be better. We already did that work when we built these priorities. So what we would need to do is basically create a better or richer data structure. It's not just storing an integer, but is storing actual parent-child relationships.
Okay. Yeah, that makes sense.
That said, I don't really think there's any harm in this setup. I mean, it's sort of a room for improvement situation because, yeah, we would make this rule and yeah, it's sort of not correct, but it would never unify because vec of t and, box of t are not equal. So like, in other words, if the original code is correct, and indeed these are unrelated impls, then this could never hold true because they were supposed to be disjoint. So eventually we should always rule it out, but it's kind of wrong and it's wasteful.
Okay. Okay, so there's a couple of things I have to go through to set this then, right? So I have to add some things to the database trait.
Yes.
I need to integrate that stuff with Salsa, but I think that's already done.
Yeah, so we have to extend the Rust AR database trait with a specialization tree or something, forest method, whatever we call it. And then we have to connect that. Right, let's see. There should be a Salsa query already, probably. Let's see. I don't recall. Wait a minute. So I put it, oh, it's in this file, query. Oh, look. So we have this coherence query. What does that do? So that's a little too broad. There's this existing query because it goes over all traits.
Yeah, it doesn't filter by the trait ID.
So we kind of want to extract this into a query itself.
Okay.
So maybe the first step is create a sort of coherence trait ID query with this code. I don't know if we want to call it coherence or specialization forest or something else, but
yeah, I was going to say we already have a coherence one, so we should change it. Specialization forest.
And then extend this, and then it can invoke the query above we just added. And then we should be able to extend the clause generation code accordingly, or to use that method and create overrides clauses. That's probably the best way to go forward, rather than, I was originally contemplating, well, should we, I mean, actually, yeah, okay. So this seems reasonable. The other option would be that for the purposes of testing, you could hard code the relationships between impls somehow. But I think that's actually probably just more work.
Yeah, that sounds like more work. Could you tell me a bit about the way we store the specialization format?
Yes. You mean like, go on. Do you have a specific question or do?
Yeah, like how is it a tree?
How is it a tree?
Yeah. So it looks like we're storing, what was it, just the impl and the number, right?
Yep.
So what makes that a tree?
Nothing, but we know that it's a tree because of the nature of the analysis. But it's not that we're not storing enough information to recover the full tree. That's the problem. That's why we might make those extra clauses.
I see.
So you're not wrong about that. But let's see, where's the, is it here?
I guess maybe I should ask, how do we build it then?
Yeah, that's what I was going to say. Why don't we just look at the code? It's not that complicated. So when you construct the specialization priorities, it calls this build specialization forest,
Yeah.
which calls this method visit specializations of trait.
Mm-hmm.
For each one, it gives you basically pairs.
Mm-hmm.
And the add edge method, where is that? Annoying. Where did I put that? Here. Well, this is where the visit specializations is. We'll come back to that. But where's add edge defined?
Use GitHub search add edge.
Yeah, I guess I have to. Wrong thing.
Oh no.
Comes from somewhere. Oh, you know what? This might be just the graph grade or something.
Oh, I see.
Let me see. Let's try to remember. Oh, forest.intoGraph. Digraph map.
Oh, it's coming from another crate. Cool.
It's coming from petgraph. Yeah, okay. So yeah, so it just adds edges into a graph. And then I don't know what this digraph map thing is.
And what is a diagram?
Directed graph for sure.
Oh, okay.
Not sure why.
Yeah, it's just a graph with directed edges. I see.
Oh, okay. So it gets converted to so a digraph map probably just means that there's a hash map mapping from the node labels to the node IDs, which are integers. So
it looks like we're storing unit.
What's that?
Looks like we're storing unit in add edge.
Oh, that's just the, yeah, so the extra data for each edge, you can have a weight on the edge.
Oh, I see.
Saying there's no weight. So then it returns a graph. This is just a graph at this point. This is actually what we really want. This is the real data.
Okay.
So it looks like we then throw that data away by calling set priorities, which essentially iterates over and says, you know, you start at depth 0. I guess externals must mean something with no incoming edges.
Okay.
You start at 0, then you visit all of its children. And since you know it's a forest of trees by construction, you kind of don't have to worry about cycles. So the question is how you get it by construction. That comes from this method. And what that method does is here. So visit specializations of trait. It goes over every pair of impulse. These are A and B, or they call it left and right.
Yeah, and then it does the check, the specialization check. Yeah, you've shown me this code before. This is fine. This makes sense. Okay. I think I understand the priority. So it's just the depth of the tree.
Yeah, so it seems like what we probably just want to do is just change that specialization priorities data structure to be to like store the actual graph.
Why didn't we do that before?
I don't think there's a real reason. I mean, this code was written without yet having a consumer. So it seems like the kind of thing that maybe, I think it was Boats that wrote it, maybe Boats had something in mind, but we've changed direction since then. So.
So one of the things you said earlier was that you'd want to iterate over all the impulse with lower priority. That's because things higher up in the tree are overridden by things lower down in the tree. Uh,
Yes.
okay. And does every trait have one tree, or can a trait be a forest as well?
It's a forest.
Because this is a specialization forest, right?
Yeah.
Um,
It's not really a tree. I lost this tab somehow.
so, like, what's an example of a
Okay.
actual forest? Because I've only
Well, we just covered one here. This was a forest, this example we did.
because
So
there's multiple.
vec of t and vec of u32 have an edge between
Mhm.
them, but box of t has no edge to either one. So
I see. Okay.
there's two trees, one of which is a singleton tree.
Cool. That makes sense. All right. I'm sure I'm going to have lots of other questions, but this has been very helpful. Thank you.
Cool. Um, Great. Then just ping me.
I will.
All right.
Cool. Have a good July 4th. Happy America Day.
You too. Happy whatever you say in Canada.
We have Canada Day. Come on. Go.
Happy Canada Day. Okay.
See ya.
Yeah.